here we have an integral involving the floor function, and now with a lot of floor function integrals we want to split this up into a series of infinite integrals because we can split this up into integer intervals. And so what we can do is split this up into the integral from 0 to 1 of the floor of any value between 0 and 1 times e to the 1 minus that same value, and obviously the floor of any value between 0 and 1 is 0, so that will just become 0. Then we're going to integrate between 1 and 2. Now the floor of anything between 1 and 2 is 1, so this is just going to be e, or 1e to the 1 minus 1 with respect to x. Next we're going to integrate between 2 and 3, and that will just be 2e to the 1 minus 2, and this continues. So we can write this out as the sum from I equals 0 to infinity of the integral from I to I plus 1 of I e to the 1 minus I dx. So the thing here to note is that this function is just constant in terms of this integral. And so this is the same as the sum from I equals 1 to infinity of I e to the 1 minus I times x from I to I plus 1. And if we plug I plus 1 minus I in here, that will cancel out to just be a 1. And so this is the same as the sum from I equals 0 to infinity of I e to the 1 minus I. So now we just need to work out what this is. And to do that, we're going to consider a function, y, which is e times the sum from n equals 0 to infinity of x over e to the n. Now, this is a geometric series, so we can evaluate it knowing that the first term is going to be e over 1 minus the common ratio, which is x over e. And so this is the same as e squared over e minus x. Now, if we take the derivative, when we differentiate this sum here, we're going to get e times the sum from n equals 0 to infinity of n x over e to the n minus 1 multiplied by the derivative of the inner function using the chain rule. We then divide by e. Now this e and this e will cancel out, and so this is the sum from n equals 0 to infinity of n x to the n minus 1, and we're just going to move this e up, which means we need to take the negative of the power, so that becomes e to the 1 minus n. Now what we'll see is that if we plug x equals 1 into here, this just becomes the sum of n e to the 1 minus n, which is the sum that we wanted before. So to evaluate what this actually is, we can also take the derivative of this expression we worked out here, and the derivative of that is just going to be minus e squared e to the minus x, e minus x to the minus 2 times by minus 1, which is e squared over e minus x squared. So what this actually tells us is that this is the same as this. Now if we want to find out what this is when x equals 1, we just plug x equals 1 into here, and we'll get e squared over e minus 1 squared. And so that's what this equals. And so we solve the integral. That's all for this video. Thanks for watching. If you have any questions or video suggestions, leave them in the comments below, and if you want to see more content like this, subscribe now.